Hi everybody, we are here again. This is Momentum Minds FS. You can reach us on our various social media. We're Twitter, TikTok, and other social media platforms. You can go to our YouTube channel, Momentum Minds FS. Click and subscribe. If you have any question, put in the comment section. I'm going to answer you and bring the knowledge of physics to your doorstep so that when you get to exam hall, you'll be self-reliant. You know what you are doing. Today we are going to look at the addition of vectors. Addition of vectors. This is different from saying 2 plus 2 is 4, 3 plus 4 is 7. That is what we call scalar addition because you are not considering the direction of the body. But vectors are quantities that have both magnitude and direction. When you handle vectors, you must therefore consider the direction along with it. For example, let us have two vectors. Let's say the first vector, F1, that's the first force. Force is a vector. Let's call it 3 newtons. And the second vector, F2, let's call it 4 newtons, as it is. Now, if the two vectors are in the same direction, this is going like this, 3 newtons. The other one is going like this. Let's call it 3 newtons, and this 4 newtons. Note that the 4 newtons force is longer than 3 newtons. As you can see, these are two parallel vectors moving in the same direction. It's very simple. You just do simple, like you're having 1 plus 1 is equal to 2. So what you do, the resultant force, Fr, will be equal to F1 plus F2. For vectors, of course, we have to denote it with this to show we are discussing a vector quantity. That's how to do it. So the resultant will now be F1 is 3 newtons plus the F2 is 4 newtons. Because both are moving in the same direction, it's going to be positive. When you have this, you get 7 newtons. It's just like ordinary scalar addition, 1 plus 1, 2 plus 2, 4. But what happens now if these two vectors are moving in opposite direction? Let us assume that you now have opposite direction. We have said the resultant force is F1 plus F2. This time, let our F1 equals to 4 newtons and our F2 let it be 3 newtons. So what you have is this. The 4 newtons force is going this way, 4 newtons, and the 3 newtons force is going opposite direction. Now, how do you have them together? Simple. Resultant force, Fr, will give you, we have said F1 plus F2 for two parallel vectors. So, our F1 is 4 newtons plus our F2 is 3 newtons. But because they are moving in opposite direction, you put plus here, you put minus to show their opposite signs of direction. So this is equals to 4 newtons plus minus 3 newtons. Of course, when you see something like this, the minus will go away. So 4 minus 3, that will give you 1 newton. You can see, when you have two parallel vectors moving in the same direction, you just add them together like 4 plus 3 to get 7. But when they are moving in opposite direction, though you cannot say you subtract them, we always add vectors. One of them will have a negative sign to show their opposite direction. You subtract them when you are in like you are working mathematics. But in words or in principle, you are still having them. We have vectors, we don't subtract them. So hope we have gained something from here. And now, finally, let us show you if these two vectors are right angle to each other, how do you do it? It's very, very simple. You just use Pythagoras Theorem. For example, I'll use two ways to describe this. If you have a force of 3 newtons this direction, and another one goes like this, and this is 4 newtons. You want to have them together. What you do, resultant, the person that starts the journey from there and turn around can easily move like this, straight on, and get there. This one is the resultant of these two forces. What do you do? This is a right angle. You use what we call Pythagoras Theorem. Pythagoras Theorem. That is the scale of the opposite of the hypotenuse. That is r squared. We give you the scale of this, 4 squared, plus the scale of this. This is 3 squared. So your r squared will give you, this is 4 times 4, not 4 times 2. 4 times 4 will be 16 plus, and this is 3 times 3, 3 in 2 places. Don't say 3 times 2, so this will be 9. So your r squared will now be 25. But we want r, not r squared. To find r now, r will now be square root of 25, and that will give us 5 newtons. So in scale, 3 plus 4 is 7. But on that vector now, 3 plus 4 is giving us 5. That is the beauty of sciences. It's also possible for the two vectors not to be arranged the way it is. You may have two vectors, one going like this, it is 4 newtons, and another one going like that, and it's 3 newtons. Now, the two vectors are facing different. This going this way, this going this way. It's not like this that you can join the two together. So what you do is that you draw a diagonal from here. From here. This will look like a parallelogram, and that's what we call parallelogram law of addition. So this will be the resultant. And after doing this now, you apply the same Pythagoras theorem to it, and you still get your 5 newtons, as we have said. So, hello students, we are showing you now how to have two vectors moving in the same direction, two parallel vectors. We have shown you two parallel vectors in opposite direction. We have also shown you two vectors at right angle to each other. That's how to solve them. As simple as ABC. Just reach us on the comment line, and we'll get back to you. If you have any questions, bring up and talk to me on it. Bye bye.